minute. He's usually a little late. Got to remember to take attendance at some point here. So I'll put my spreadsheet up to remind me. Okay.
Have you posted the new video project?
I just did it. So if you didn't get the email, for some reason, the video that I converted from jar file to the MP4 had about 20 minutes of the video missing. So the video should be 40-some minutes long, and it was only 20-some minutes long, which I didn't realize until I kept getting these questions about, you didn't show how to do the Z-score. And like, oh, I thought I did that. So.
It was set up to follow the video, and I had gotten right where the video skips on my own before loading up the video.
Yeah.
So right when it got to the point, it was like, okay, here we go.
Yeah, and then.
And noticed that there were 3 sheets all of a sudden. I was like, oh, well, hopefully.
Yeah, no. So yeah, I didn't realize that. So I fixed that. It is now 40-some minutes long. And it wasn't like I forgot to do it. It just, I can't. Maybe I accidentally deleted part of it when I converted it. I don't know. Doesn't really matter. Just now it's fixed. So I'm going to give you an extra 2 days to finish that. If you've completed what you've completed is still valid, so it's not like you're having to do extra work because I messed up. You just have to finish off what I had you doing. So that'll be due next Thursday instead of next Tuesday. So we are going to finish up chapter 12, and then we're going to move on to chapter 13, which is about personal finance. And I'm going to somewhat follow the book, but I'm going to cover some material that's not in the book that I feel is important for people to know. You may not think it's important now, but at some point you will think it's important. So hopefully you'll remember some of it, or at least it's like my daughter. She's, Heather, the one that just had the baby. She's 30. Should be 31 this year. And so she has a job where you have a savings. You have a 401k program. And I think nowadays they put you in it by default. You can opt out of doing it, but they put you in it because what they found is that if they put you into it, you won't leave because you think, oh, maybe it's a good idea because they're putting me in it. I don't want to go to trouble. It's probably a good idea. But if they don't put you in it, nobody does it. And what do you lose by getting put in it? Nothing, except you have less money in your paycheck, but you are saving it, which you can use later anyway, so it's not like you're not. But if you don't put money in and you get to retirement and you don't have any savings, then you're going to be, one of those old people that is going to the food bank and things like that. So it's and she asked me about, she said, Dad, what's the difference between a Roth IRA and a traditional IRA? Yeah, that's the base. That's the general concept. Is there an advantage? What are the advantages of one versus the other? Why would you do one over the other? Because you think. So we'll talk about that. And it was kind of funny because I actually did the calculation. I said, okay, if I put my money in now, but I get the tax, I don't have to pay tax on it now, and then I get a certain amount of return on that investment, but then I have to get taxed on it later versus that's the traditional IRA. If you pay tax on it now, the money that you accumulate over that investment time period is not taxed, and then when you take it out, it's not taxed. Does that really make any difference? And the answer is no, if you are in the same tax bracket when you work versus when you retire. It all comes down to if you expect to be in a lower tax bracket when you retire or in a higher tax bracket. And you might think, higher tax, that means I'm making more money than when I put it in there. Is that likely or not? Well, it depends on how much money you save. If you save a lot of money, you can actually retire and get more money in retirement than you can when you're working. If you do it planned correctly, if you end up where you don't save any money and you're just getting Social Security, then you might be making a lower tax bracket. So it all depends. And it turns out that if you are in a higher tax bracket when you retire, the Roth IRA is better. If you're in a lower tax bracket when you retire, the traditional IRA is better. And if you're in the same tax bracket, it doesn't make any difference. You kind of have to make some assumption of which way you think which way you're going to go. Anyway, so I told her that. Sometimes you're tempted to do the traditional IRA because you put the money in, you have to pay like taxes, so you might be paying $1,000 taxes. If you do an RIRA, you'll put the money in the bank and you won't have to pay taxes, but you ultimately have to pay taxes on it. There's some other things that relate to how you can take it out, and if you're going to no, it accumulates interest. The interest is, in both cases, the interest is tax. Well, for Roth IRA, the tax is the interest is not taxed. The other nice thing is it makes your taxes a lot easier because all the investments you have in IRAs you don't have to pay tax on during the year, so you don't have to report it. The banks report it, but you don't have to put it in your tax return. So if you have 7 things that you have invested in, you don't have to report it and do all that stuff until you take it out. Then you have to do it. Okay, but we'll talk more about that stuff. That's one thing they don't talk about in the book, but that's a question that you're probably going to run into at some point. Okay, back to these normal distribution problems. So what we've mostly looked at is we have a mean and a standard deviation, and we have 2 values, and we say, is what percentage of the data is above a value, or below a certain value, between certain values. Now, you can also just be given the z-scores, which is just a simplification of what we've been doing in the past, but some of your homework problems involve that. So we worked one problem last time, this one here, between 1.41z and 1.83z. And in that case, we subtracted the values because they were both on the same side of the 0 point. Here, they're on different parts of the as far as the sign is concerned. So again, remember that when you draw your representative figure, when you're just dealing with z-score, the distribution is centered around x equals 0 instead of around the mean. So that should have been let's just slide it over just a little bit, like that. So what they're asking here is what percentage of the data would be between a z-score of negative 1.98, which is over here, and a positive 1.02. So if you draw vertical lines from those z-scores, you'll see that we have an area to the left of the mean, or a z-score of 0, and an area to the right of the mean. The only difference between what we've done before is the z-scores are already calculated. We don't have to do anything. So what we would do is we would find the area under the blue hashed area, which is from the mean to negative 1.98z. But what we would do is we'd use z equals positive 1.98 to look up the corresponding area, because we don't have a table that uses negative z, but because it's symmetric, it doesn't matter. So I forgot to bring in my table today, so I'm going to just go back and forth. Actually, I think I'm going to drag it so I don't have to I'll make a clone of it, and I'll put it nearer to where we're. So clone the page. I guess I have to drag it. Okay, so I'm just going to drag this thing down. Okay, not sure if that's still going to go further. Maybe that's it. Nope, still further. I only have to do this one time, so how about that one? There we go. Okay, so now we have the table. So we look down on our table. If you have it, go ahead and pull it out so you can make sure you know how to do this. So we look for a column that has Z of 1.98, which would be this column right here. We scroll down. We see 1.98. The corresponding area is 0.476. So the area underneath the blue hashed in area is 0.476 out of 1. And then we would use the second z-score, which is positive already, so we don't have to make it positive. You would then look up the area associated with the z of 1.02. So we'll look over here. 1.02 looks like it's down near the bottom of the second bunch. So it's right there. We get 0.346. And so the total area, so to give us the total percent of data that is between a z-score of negative 1.98 and positive 1.02, we add the two parts together. And we get 0.822. So what does that mean? It means that 82.2% of the data is between z equals negative 1.98 and z equals 1.02. Now both of these numbers actually are close to some kind of rule of thumb that we have. You know, 1.02 is close to 1. And the rule of thumb says 65%, I think. 65% of the data is between plus or minus 1. So if I take half of that, half of 65 would be about 32, which is close to this number. And negative 2z is close to 2, negative 1.98z is close to negative 2. 2 standard deviations says approximately 95% of your data is between plus or minus 2 standard deviations. So if you went between minus 2 and 0, it would be half that amount, which would be half of 95 is 47.5. And you see it's very close to 47.5. So if you add those two separately, so this is like almost minus 2 to plus 1, you get 80%. If you went plus or minus 1, you'd have 65%, which is less than that. If you went plus or minus 2 standard deviations, you get 95%, which is above that. So that makes sense. So last night, I was watching the new, I'm in this brass group. I'm playing my trumpet for the first time in 40, well, I've played it a few times just until my wife comes home and then she says, don't play that thing anymore. She still says that, but I just go home a little early and practice while she's not there. So anyway, after I got back from band practice last night, so it's a brass band. I was watching the news. So I had first, it was on MSNBC, you know, mainstream media, and but fake news. And then I turned it on Fox News for a while, and they were both talking. That's right. So I listened to, and it was Sean Hannity, which on Fox News, and they were talking about the same thing, and I'm thinking, are these people on the same planet? You know, I'm sure that it was just crazy the difference in this. It was about the claim about wiretapping. So what's that? Spygate, yeah. Oh, is that Belichick? Yeah. So it was interesting. I mean, Hanvey says he's not a news person. He's a whatever. You know, but yeah, it was mind blowing. I'm just like, this is the same thing, and the spin on either side was just crazy. What happened? Just so you know, what happened was the head of the House Intelligence Committee heard from somebody, unnamed sources, that some of Trump's transition or some Trump's team was inadvertently caught in a surveillance. So they weren't surveilling them, they were surveilling foreign entities, and they had somehow either names were mentioned or they were part of the conversation. And normally what they do if an American citizen is on that call, they will, when they have the transcripts, they'll mark the person's name out. They'll leave them unidentified. What this guy said was, even though the name was left off, because of the context of the conversation, you could figure out who it was. So it wasn't really, it's like somebody calling into a news station says, I'd like to be anonymous, but you know, they sound like Donald Trump or something. You know, somebody has a recognizable voice. And so, you know, they were not entirely anonymous. And so this guy thought that was bad because you could figure out who this person was. So I guess the question is, do you not show the transcripts to anybody in the government because you can figure out who it is, or you just ignore it because you can figure out who it is? So it's an interesting concept. So, but the Fox was spinning it as, well, see, they were wiretapping Trump's offices. They were not, okay? But they were, it was just so, and Obama was a bad guy for doing this. Okay, that was it. So that was the Fox spin, and then the MSNBC spin was this guy from Congress going to Trump and saying, hey, we found this out, without going to the committee and keeping it, you know, they're supposed to be checks and balances, not in cahoots with the other guy. So that was their spin, that, you know, so it was, and I'm just scratching my head there thinking, wow, this is crazy.
Okay, here is your attendance question. I want you to go into the table 17 on page 671 in your book, and I want you to look up for a z-score of 1.3, what is the corresponding area? It's 0.4 something.
Okay. Another way of doing these problems is that you actually start with the area and then work out the corresponding z values that make that happen. So this problem, 23, says find the value of z such that each condition is met. And it's the same kind of procedure. You draw a picture to figure out what the heck is going on. And then you just have to go in the backward direction. So let's do one. We'll do two of these. So what it's saying, it says find the value of z such that this condition. So here we have our, so we don't even have to read the problem. It's like, oh, it's something to do with z-score, so I'm going to draw this normal distribution as a function of z. And it's going to go from -3 over here to +3 there. It says 10% of the total area is to the right of z. So let's just think about where, if we drew different lines, whether, you know, just if we didn't really know what the heck we're doing, let's draw a line here. So if the total area under here is 100%, would this, if I put the line here, would that make any sense as far as this problem is concerned? Well, you'd say, well, I've got a small area here, but that's to the left of the red line. So that's probably not what we're talking about. If I talked about the area to the right, well, I've got 50% of the area here plus some more. Obviously, the area under this, to the right of this curve is much more than 10%. So that probably is not the right place to put it. So it's probably not a negative z-score. How about if I take that line and I move it over there? So now I look at it and I think, okay, what's to the left? I've got 50% plus some other percent. So that's not going to be the right area that I'm talking about. So if I go to the right of this, I've got this little bit. And that looks reasonable because this is 10%, 10% is 1/10. So this looks at some fraction, small fraction of the whole. So that looks like the right scenario, which it is. Okay, so what we're looking for is the area in this little sliver. And we want to find out what is the z-score associated with that particular scenario. But we say, well, the tables that I'm going to use are based upon the area from the mean. This is not from the mean, so how do I get this part using information from the mean? Well, I say, well, half of the area is 0.5, and if I take this area, which is less than 0.5, and I subtract it from 0.5, that'll give me the little bit that's left over. So what I'm trying to do here is come up with an area, and the area is not 0.1. The area that I'm going to use to find the z-score, the area is equal to the area to the right of the mean, this whole thing, minus the area associated with the z-score, well, the area of 10%, okay, which is the red area. So I'm going to take 0.5, subtract 0.1. The area that I'm going to use for my table the backward way is 0.4, 0. So rather than looking at the z-score, I'm going to use the area and go the opposite direction. So in the past, we've found the z-score and gone to the right to find the area. So now we're going to find the area. We're going to look up the area and go to the left and find the z-score. So if you look at this table, we're going to go down the column till we find an area of 0.4, and there it is. So we go to the left, find the z-score. The z-score is 1.28. Okay, so it's just backwards. So using the table, z equals 1.28 for the area equals 0.400. And that's the answer. Okay. In this case, they're just asking for the z-score. What z-score is going to have it so that 10% of the data is to the right? Okay. How about 4% to the left? So here we had this, we had our area on this side because we were looking for a small area to the right. Consequently, let me just take this and clone it. So it's going to be the same thing. I don't know why I grouped that, but it did. Group. Okay. So what we're going to do is, in this case, we're going to take this over here. And, it's not the exact same area, but it's the same. You don't have to be exact here. You're just using this for illustrative purposes. So this area here has to be equal to 0.04. So as a consequence, the area that I'm going to look up in the table is 0.5, which is the area to the left of the mean, minus this little bit, 0.04. So that's 0.49 or 4.460, right? So instead of looking at 0.4, I'm looking at 0.46. So you go to the table. Let's go ahead and expand that out. So we're going down the table looking for 0.460 right there. That's 1.75. So the Z for an area equal to 0.46 is 1.75. So is that the right answer? Why is it not 1.75? Yeah, it's negative. So we have to reflect what's on the graph. It's actually negative because the tables only give us positive results. So because of our figure, Z must be negative. So Z equals negative 1.75. So actually, we're going to go back and do a problem that we did the other day, our cereal box thing here. And we're going to ask the question differently. Here they originally gave us a standard deviation. So part B of this problem is if the mean is 24.5 ounces, the standard deviation is 0.3 ounces. Actually, let's not do that. We're going to figure out what the mean has to be. If the mean is an unknown, the standard deviation is given, and we want to only have 2% of the boxes less than 24 ounces. Calculate mean. So we can determine the standard deviation by just running trials on the box machine. The labeling sets the minimum. That's what we're going to advertise as the amount in the box. We're only willing to have 2% be less than that because we feel that's either being a good corporate citizen or what we can get away with. So how do we solve this problem? Well, again, what you need to do is draw a picture and figure out what the heck we're talking about. Excuse me. That's good. So actually, we're dealing with numbers here instead of z-scores. So back this thing up. So here's my distribution. This is my mean, which I'm trying to figure out. This is the x value. This is equal to 24 ounces. And I only want 2% to have less than 24 ounces. So how do I solve this problem? Well, let's think about it. Can I find a z-score associated with what I know so far? Because for the z-score, you don't need to know the mean or the standard deviation. You just have to use the tables. So what we'll do is we'll say the black area is 0.02. Then we have our area that's between the mean and that particular thing. So therefore, the red area in this case, sorry, you probably don't have colored pencils, is what? Not 9.8. We're going for the mean, 0.48. Okay, so the red area is 0.48. So with that red area, we can find the z-score. Find z-score that will give us that. So we use that. We go back to our table again, which is way back here. Where'd it go? There we go. Okay, so we go for an area of 0.48, and we actually have two numbers, 2.05 and 2.06. So let's use 2.045, okay? So taking the average of those two, 2.045. So we get z equals 2.045. Now, what is the z-score? Z-score is x minus x bar divided by the standard deviation. So the only way we can use this equation to solve for something is if we know 3 out of the 4 things. In the past, what we've done is we've usually had the mean, the value, and the standard deviation. But let's look at what we know. Do we know the z-score? Do we have a z-score? Yes, 2.045. Do we have a standard deviation? Yes. Do we have a value? Yes. So that means we can solve for the value that will cause that z-score to happen. So one way would be just to plug the numbers in. So let's just do that and then do the algebra. So you get 2.045 is equal to, x is equal to 24. We're trying to figure out what the mean has to be for that to happen. We divide by the standard deviation, which is 0.3. Okay. So we're going to multiply both sides by 0.3. So we're going to do that. The left-hand side becomes 2.045 times 0.3, which is 6.6135 is equal to 24 minus x bar. And then we subtract 24 from both sides so that we can get this by itself. So if you subtract 24 from that number, you'll get negative 23 point, oops, sorry, something's wrong here. Oh, do you see what I did wrong? That's the z-score out of the book. The z-score that we have to use is negative, okay, because it's down here. So that's negative, that number. So when you subtract 24 from negative 0.3, so it's negative 0.6135 minus 24, you get negative 24.6135 is equal to negative x bar, or the mean has to be 24.6135. Obviously, we're not going to be able to do it to that exactly, but and the reason I knew I messed up, you know, how do you know you mess up? That's part of being a good math person, is you make mistakes and then you recognize mistakes. Trump must not be good at math because he can't admit mistakes. So the what happened was when I had a positive number and I subtracted 24, I got 23. And then 20, you can't have the mean less than the average or the minimum, or that doesn't make any sense. So that's why I said, oh, I did something wrong. So then oh yeah, okay, I forgot to put the negative sign there. So our previous problem, they had a mean of 24.5, which in that case you had something like 4 or 5% that would be less than its target. In this case, I decided on a percent that I determined to be acceptable, and then I worked back to figure out what the target would need to be. And it has to be a little bit more than the previous problem because I wanted to have less of them that are below the requirement. So that's my business decision for the day. And the last thing is these problems 58. What they're looking for there is basically what we've just done here, is you're not actually even using the table. All you're doing is saying, I'm given in this problem, or this set of problems, I'm given that the average is 76.8, the standard deviation is 9.42. They're asking what is the actual value to give me a z-score of negative 2.39. So it's exactly what I just did here, except it's not part of a problem. It's just a math problem. And so to do that, what I'm going to do is, before what we did is we plugged the numbers in, and then we solved. But most of the time in the real world, you don't do that, or at least in physics, I don't do that. I solve for what I'm trying to figure out algebraically, and then I plug the numbers in. So don't plug the numbers in. So how do you do that? Well, what you have to do is pretty much, these are all variables. You have to treat them all as variables. But you use the same rules apply for variables as for constants. So what I would do is I multiply both sides by s. So I'd get s times z is equal to x minus x bar. So instead of multiplying these two numbers together, I'm multiplying the variables. Then I would subtract x from both sides, so I'd get negative x plus s times z is equal to negative x bar. Actually, in this case, I'm solving for, this is what I did in the previous problem, but for this problem, I'm looking for what is this value. So I'd add x bar to both sides, so I get x bar plus s times z is equal to x, or switching sides, x is equal to x bar plus s times z. So that's the equation that I need to use. And why do I do that? It's because if I have problems like this, I don't have to do the algebra anymore. I've done all the algebra symbolically, and then I can plug it in. So for our particular case here, for problem 58, x bar is 76.8, standard deviation is 9.42, the z-score is negative 2.39. Therefore, the corresponding value, x, is going to be less than the mean, because it's a negative z-score. And I get 54.3. So that is this is round to the nearest tenth. Find the data values corresponding to the z-score. So now if I took this value with this standard deviation and this mean, I would get a z-score of negative 2.39. So once I have this equation, and I get another problem, which I'm going to change to, say, 1.25, what is the corresponding value that gives me a z of 1.25? All I have to do is use this equation now. The value is the mean, 76.8, plus the standard deviation times the z-score. And then everybody can do that calculation. 76.8 plus 9.42 times 1.25. And so the value would be 88.6. So that's how those problems work. it's not really using the area underneath the curve. It's just showing if you had the area and found the z-score, what would be the corresponding value associated with that? Which is what we did in a previous problem, but we plugged the numbers in and then we solved for it. In this case, I'm solving for it and then plugging the numbers in. Okay, so that's the last part. One last bit. This is apparently from a few years ago. I found this. Results listed by average IQ. This was the 2004 election. So we had President-elect John, the president they were voting for, John Kerry was one person, George Bush was the other one. And then they listed it in terms of the average IQ for the population of that state. And so Virginia had, back then, had an IQ of 100, which is average. You got these northeast states up there. Let me put them on one sheet so you can see them. So we're average as far as IQ is concerned. Yeah, Mississippi, average IQ 85. So I'm just presenting the data there. But it's kind of yeah, it's interesting how that, where they got that from. I don't know where they got the data from, but that's an interesting. We were talking about IQs. I would, surprising that it's, I mean, what was the standard deviation for IQ? It was 15. So they're saying that, I mean, there's a big difference between 113 and 85 as far as. Yeah. Okay. So that's it for chapter 12. So we're moving to pardon me? So any statistic that's negative. Well, at least if you're average and you move to Mississippi, you're now automatically above average. Yeah. So we're going to talk about personal finance. Like I said, some things that are in the book, some things that are not in the book. I have gotten reviews from previous classes that, well, it was one person made some comment about my discussion of personal finance. And basically it was saying, you shouldn't interject your personal opinion into the problem was I wasn't interjecting my personal opinion. It's just that I guess most things can be politicized, even money. And anyway, I'll let you know if anything is close to being a personal opinion or not. But yeah, it is to some extent. Yeah, depending upon. Yeah, I think that was the point, was the strategy question. What do you do? And there are things that are so black and white as far as whether they are good or bad. There are other strategies that are questionable. Yeah. Mm-hmm. Yeah. That would be a personal opinion. Okay, I think buying, diversifying your stock holdings, that is not a political. That's probably about as much as I got as far as personal opinion is concerned. Okay, so we're going to talk about saving money, buying things as far as on loans, what different options you have for investing your money, and what the advantages and disadvantages of those are. Because, you know, the alternative to saving money, besides spending money, is just to put it in an envelope and stick it underneath your mattress and come back later and hope, you know, it's still there, or burying it or whatever, you know, or just sticking it in a checking account and not getting any interest on it. And ultimately what happens is that, you know, the amount that you can buy with that money when you take it out years later is less because of inflation. So to be able to, even to just counteract inflation, you've got to do something with it. But the different things that you can do with it carry different risks associated with it, and also different fluctuations in the value with time. So typically the more you get for lending your money to somebody for whatever reason, the ones that give you more return over the long term tend to be more variable in the short term. So we'll talk about those kinds of things. But the first thing we're going to talk about is just the time value of money. This is the simplest. Whether you're investing in CD, certificates of deposit, which are safe but not very rewarding, or you're investing in the stock market in shares of Snap Incorporated, you know, those have different returns, but the value of that return over time is the same concept. So I'm just going to use a simple example about putting some money in a bank account, which is what probably the easiest one to understand. So let's just talk about this. So let's say I deposit $1,000 in a CD, which is called a certificate of deposit. So that doesn't stand for compact disc, even though nowadays people are probably forgetting what compact discs are. By the way, do you know how so this is relating to back in the old days when you had an artist, a musical artist, and you ranked them. There was a chart, the Billboard top chart, you know, there was, and back then when you had no streaming and you just had albums, or you had 45s, or you played it on the radio, you know, determining the popularity of a song, you would have physical things to measure. Okay, so if you sold 1 million albums and this person sold 100,000 albums, of course the million album would be considered more popular. Nowadays, a lot of music is listened through streaming, and how do you quantify a stream versus a purchase? Yeah, so, and it's surprising how little the artists get per stream, you know. Yeah, yeah. Yeah, that's true. That's where artists get their money these days, is touring, not through the actual selling records. You can't be a studio artist very much anymore. You've got, you know. So I forget the number. It's like 1,000 streams equals 1 sale. So, you know, you think about buying a CD. Are you going to listen to it 1,000 times, the song 1,000 times? It seems like they're underselling the the streaming. I would think the number of listens would be something that would. Anyway, that's an interesting. Yeah, do people listen to it, or they just, Anyway, there's a whole, it's interesting, the whole concept of music, making money in music. Anyway, we're making money here by putting them into a certificate of deposit at an interest rate of 5% for 5 years. And we're going to compound yearly. How much money do I have after 5 years? Question mark. Okay, so how does this thing work? So here's the start. Okay, if I put $1,000 in to start with, I have $1,000. Okay, I don't get anything. I'm not getting bonus, signing bonus, or anything like that. Even though theoretically they might give you to encourage you and to entice you. It's like a bonus on your car, cash back on your car. So you can get a cash back, which is a reward for buying it. So but in this case, we're not getting any benefit from putting it in there. So the first time something happens is after 1 year. So after 1 year, what they do, and that's after 1 year because we're compounding yearly, you get a reward for having that money in the bank. So they can use your money to make loans for cars and stuff like that. So after 1 year, you have some reward for that, which is called the interest. And the interest, the yearly interest, is going to be the principal times the interest rate. And it's the interest rate in percent, in decimal form. So in our case, our principal is $1,000, and our interest rate is 5%, so the decimal equivalent of 5% is 0.05. So if you multiply that together, you get $50. So we'll say at the beginning of the second year, so right immediately after the first year ends, the principal, or the amount that's in the account, is going to be your $1,000 you had initially plus your $50 that you got as reward for having your money in there. So you have $1,050. Okay? So instead of just getting, in the second year, instead of getting interest on $1,000, you get interest on a larger amount. You get credit for that amount. That's what compounding is. You're adding on to your principal each year, so you're not only getting interest on the original amount, but on the accumulated amount. So after 2 years, again, you can calculate the interest for the second year. It's the same thing, but in this case, instead of $1,000 as your principal, you have now $1,050. You still have the same interest rate. So that's not going to be as easy to calculate, so let me use my calculator. 1,050 times 0.05, you get $52.50. So we earn another $2.50 the second year. So what we can say is at the beginning of the third year, our principal is the value that we had at the beginning of the second year, which was $1,050, plus the interest that we have earned during the second year. So the principal now has increased to $1,102.50. If we didn't if we didn't include this interest added on, we would just be keep getting $50 each year. Now, theoretically, if you came after the end of the first year and you took the $50, give me the $50 now, then you wouldn't have any more money there. So it's leaving that accumulated money in the account. Now, rather than doing this for the entire 5 years, the mathematical expression which takes all this into account says that the amount of money in a savings account or any kind of account that's building interest, building value, is equal to the principal times 1 plus the interest rate raised to the nth power. So let me define those. So A is the amount after n periods, which in this case is yearly. P is the principal. That's the amount that you put in initially. So we'll say that's the initial amount. R is the yearly interest rate in decimal form. And N is the number of years. So this thing of 1 plus R to the n power is this effect of putting the money back into your, keeping the money that you get for having it in a year, leave it in so you get more interest on it. So for our particular case, the principal was $1,000. The interest rate was 5%, which is 0.05, raised to the number of years, which is 5. So this is when you need a calculator that does exponential. It's hard to do. Well, because that's the easiest one to start with. Yeah, that's right. Yeah, it's interesting. I mean, when I first opened a savings account as a kid, it was compounded quarterly. Now pretty much everybody does what's called compounding continuously. There's not a huge amount of difference between compounding quarterly and compounding continuously, but it's just, it gives you the maximum value. Yeah, you wouldn't want to do that. So we get $1,276. If we didn't compound it, if we had no compounding, it would just be, the amount would be equal to the original amount times 1.05 times the number of years. I think that's right. Let's see what it comes out to be. So you get 1,000 times 1.05 times 5. Oh, that's not right. What it is it's going to be equal to 1,000 plus the original amount times this times the interest rate times 5 years. Okay, so let's see what that comes out. I think it comes out to $1,250. 1,000 plus 1,000 times 0.05 times 5. $1,250. Okay, so that would be without compounding it. And your first thing is like, well, that doesn't make a whole lot of difference, right? You get $250 here, you get $276.28 there. It's more. It's not hugely more. Okay. Now, so it doesn't. I mean, the time value of money there, you are getting. The compounding, like I said, helps some. The most important thing is that you are getting that interest every year. But let's look at another example. Let's say your grandparents decide to leave you $10,000. Okay, so you've got $10,000 and you're 20 years old. and you think, instead of buying a new car, I'm going to put that into the stock market. And the stock market, the return on the stock market is historically, okay, it's not, now it's not this much, but if you did it for the last 80 years or 40 years before 2000, the year 2000, it averaged something between, I think, 11 and 13% on average. Somebody used 11%. So the decimal equivalent is 0.11. And the number of years is 40 years. So I'm gonna keep it till I'm 60. The question is, how much money would I have accumulated if I continued to reinvest my money back into the stock market and not touch it? You know, like, oh, I forgot about that account that I put in there 40 years ago. Let me see how much money I've got in there. You know, just ignore it. So you'd use the same equation. You'd say the amount is equal to the principal, which is 10,000 times 1 plus the interest rate raised to the nth power. So let's see what we get. $10,000 times 1 plus 0.11 raised to the 40th power. 10,000 times 1.11 raised to the 40th power. So we take our calculator. 10,000 times 1.11 raised to the 40th power. And you get $650,000. So that's a little more impressive than the original example. Now, what have I not taken into consideration about?
You're assuming the investment's going to match or beat the S&P.
Well, not that complicated. Not related to that. What about buying stuff? So I'm using this money to buy stuff. I'm not just saying I got a lot of money here. It's like a millionaire. You know, now millionaire is not as impressive as being a millionaire 20 years ago because, you know, you can't buy as much stuff with $1 million or whatever. So the value of your money, just like I said, when you put your money in an envelope and stick it in the mattress, if you're not getting any return on it, 10 years from now you can buy less of that money than you could now. And so you may say, well, that means I should just buy everything now because it's going to cost more later. But so you have to take into account inflation. So the question is, how much in 40 years, assuming a certain inflation rate, how much is it going to cost to buy the same thing 40 years from now? And so what you could do is you could take the ratio of what you have to the cost of something. So what is the inflation? Does anybody know what the historical inflation rate is? What's that? 2% is, yeah, that's what they want it to be, 2%. So it's been a little less than 2%. During the 80s, it was much higher. And then in countries like Venezuela, it's 50% a year. So it's really high. So, but the Fed, the Federal Reserve, likes to use, and the government likes to keep it at 2%. Now, why wouldn't you want it to be 0? Well, because if it's 0, then it usually means the economy is not growing. So you like 2%, so the economy is growing, but it's not so high that the value of your investments or your savings is dissipated through the years. So that's a good answer, 2%. So what you would do is to look at how much more stuff costs. You do the same thing, but you would use 0.02 instead of 0.11. So we'll say something costs $10,000 now. How much is it going to cost in 40 years at 2% inflation? So you take 1.02 raised to the 40th power times 10,000, and I get 20,100 approximately. So it's going to cost about twice as much. But if I take the ratio of what I have, 650,000 divided by 2,100, $20,100. That is 32.3. So it means in 40 years I can buy 32.2 as much stuff as I could buy in when I had the $10,000. So it's still a good idea to do that if you can get 11% over the life of the investment. So instead of buying, you know, back 40 years ago, $10,000 might buy you a probably buy you a couple of cars, maybe. Whereas, you know, here you can buy 32 times as many cars, or you can buy 32 more expensive. So it's more impressive when you do it over a longer period of time. The key thing here is the difference between these two numbers, the return on your investment and the inflation rate. So the higher the inflation rate, the bigger this number is. 20,000 is going to be larger, so you're going to buy less. Your money in the future is going to buy less stuff for the same amount of money, or you're going to cost more to buy the same stuff. And if your returns are low, then you're not going to have as much money. So you try to get that number as far apart as possible. You don't have much control over the inflation rate. You have no control over the inflation rate, but your government might have that control. The only control you have is deciding where you put your money, and also hoping that the economy is strong enough so that this is a reasonable amount.
Everybody worries about that. Every generation is like, we might not perform.
Yeah, they do.
And that's shit.
Yeah, you kind of have to do it, because if you don't do it, it's the paradox of the, it's the, what is it? I forget who's the guy who did this, but it basically says, you know, do you believe in God or you do not believe in God? Okay, so if you, is it Pascal? Yeah. So what the concept here is that if you don't believe in God and there is no God and you die, then the result is you just nothing. Okay. If you don't believe in God and there is a God and you go to hell because of it, you're going to be in trouble. Okay, so the other person is somebody who believes in God. If there is no God, then you die and nothing happens. And if you believe and there is a God and you go to heaven, then you get a reward. So you know it's kind of the same thing. So it's kind of the same thing with the stock market, is that you cannot believe in it or you don't think it's going to work. But the alternative, which is putting it in a CD, means you're not going to ever have enough money to retire. So you almost have to believe in it to some extent and hope that it's going to work. Because if it doesn't work, you're screwed either way. Yeah. So, yeah, you don't want to put all your money, you know, you don't want to, but you got to, yeah. So that's what people don't understand, is and I didn't understand that when I was younger. I tried to be too conservative, and I mean, I'm still okay, but I could have made a lot more. For example, here's my last little story. When I left, I worked for General Electric for 2 years. When I left, I found out I got 2 shares of stock for being there 2 years. I didn't expect it. It's still in GE stock. I just have left it alone. So back when I got the stock, it was worth, I think, $100 a share. So I had $200. This was in 1982. And I've just left it in there. It's grown. It's actually gone up and then got back down again.
Okay, your second attendance question for this lecture is the same as last time, except I'm going to pick a different z-score. So for a z-score of 2.24, find the corresponding area. So z of 2.24, find the corresponding area from table 17 on page 671.
But even gone back down again, that $200 now is worth $5,000. Okay, so if I thought back, if you take the ratio, if I had bought $10,000 worth of GE stock when I left, which I don't know if I had $10,000 to spend, but they did, but I didn't do it because I was young and I didn't think I needed to. So if you take the ratio of what actually I got free to what it's worth right now, And if I took that and I multiply it by $10,000, which was, you know, it was probably about a third of my paycheck for the year at that time, which is still pretty good. If I had invested that $10,000, it would be worth $250,000 now, which would be that's 25 times the original amount, which is pretty darn good. But I didn't do it. I was lucky that, I mean, it's worth $5,000 now, which is, you know, it's not, I can't retire in $5,000, but it's still a nice chunk of change that I didn't expect to have. So anyway, that's my little example of how the stock market. And so if you have a job and they automatically start pulling stuff out and you put it in an index fund, which is a diversified array of stocks that match the certain stock markets, and you just let it go and don't worry about it until you retire, you might have a surprise, a pleasant surprise. But if you don't do it, there's no chance that you're going to have a pleasant surprise. So anyway, I'll keep telling you that kind of thing. So that's it for today. We'll see you on Tuesday. More wisdom from experience here. I didn't always make the right decisions. I have no idea. Oh, really? Okay.